Welcome to Ajay classes. Today we will study about reflection of light through a spherical mirror. Now let us see how the light gets reflected from the surface of the spherical mirror. We will see the necessary sign convention required to decide the object distance, image distance, focal length from the pole of the spherical mirror. Now let us see. Reflection of light through a spherical mirror. There are two kinds of spherical mirror, and one is concave middle point is the pole. We draw a principal axis. Principal axis is the imaginary line passing through the center of curvature of the mirror to the pole of the mirror. And for convex mirror, we can also draw in freehand. Yes, we will decide the principal axis passing through the pole as well as curvature of the spherical mirror. To both the kind, for concave mirror and for convex mirror, the point which acts as an origin to measure all the distances along the principal axis is called pole of the mirror. This pole divides the aperture of the given spherical mirror in two parts for both the kinds of. Now we will locate the point P from the center of curvature. We call it as radius of curvature. Radius of curvature is the distance between the pole of the given mirror and the center of curvature of the mirror. This is called radius of curvature. For both kind of the spherical mirror, we define the same, both having the same meaning for both kind of the mirror. The distance between the pole and the center of curvature is the radius of curvature. Now the another point is between the center of curvature and the pole, we call focus, because all the rays which are coming from the infinity must pass after reflection through a point which lies on the principal axis. Principal axis is the focus, is the point through which all the ray of light passes after reflection from the spherical mirror. Similarly, for convex mirror, we can also decide when the ray of light coming from the infinity incident on any point on the convex mirror, it gets diverged out and it appears to come from a point which appears to lie on the principal axis, and it is called principal focus. And the distance between the pole and the focus of the mirror is called focal length. Now this is very important point to decide the focal length of the convex mirror or as well as concave mirror. The point location of the pole and the principal focus and the distance between these 2 points is the focal length. So for the distance of the pole and focus and distance from pole and center of curvature, these two value gives focal length and the radius of curvature. If we keep any object in front of the spherical mirror, if we keep any object in front of the spherical mirror, the object distance must be measured from the pole of the mirror, and we call it U. U is the common representations of the object distance for both kind of the object. If you are keeping the object similarly in front of the convex mirror, A and B is the height of the object, and after reflection we see. We can decide the distance of the object from the pole of the mirror, and we will write always U. So because of the reflection of light, after reflections all the rays of light is falling toward in front of the mirror, and now we will decide image distance. How to decide the image distance? The rule is that ray of light must pass, one of the ray of light must pass, one is parallel to the principal axis and incident on the any one point of the concave mirror, and that is reflect back. Another ray may be allowed to pass through the center of curvature, and it goes directly toward the another point to the lower apertures of the concave mirror, and ray of light when passed through the center of curvature returns back after reflection from another part of the concave mirror and retraces the path and makes the image which is inverted for the concave mirror, and we get the inverted image A dash and B dash. So how image is formed? By retracing the path of the light, bouncing incident on the any one point of the concave mirror, and then passing through the focus and goes down, another ray passing through the center of curvature and incident on the lower part of the concave mirror and return back, retraces the path and makes a real image inverted. The distance of the image from the pole is called image distance. So we have seen here how to decide the distance, how to decide the image distance, how to decide the focal length, and how to decide the radius of curvature for the concave mirror. And in the similar way, we can also decide the image distance through the convex mirror. We know that when the light incident on any one point on the convex mirror, after bouncing back, after reflection, the ray of light appears to come from the focus, and another ray which also passes through the tips of the object, and that must pass to the center of curvature, that must incident on the convex mirror, and it may appears to pass through the center of curvature. It forms a virtual image behind the mirror, A dash and B dash. The another way to decide convex mirror forms a virtual image, an erect image just above the principal axis. A dash B dash is the virtual image, and it is formed behind the mirror. We can decide easily the object distance V measure from the pole. So in both the kind of mirror we have seen the object distance, image distance, focal length, and radius of curvature. These four terms are very much important for the spherical mirror, and now we will decide the sign convention. According to sign convention, we see that the important sign conventions are: number one, all the distances measured in the direction of light for any kind of mirror, the distances are taken positive. All the distances measured in the direction of light are taken positive. The second sign convention is that all the distances measured against the direction of light are taken as against the direction of incident light, against the direction of incident light are taken negative. So these two rules to decide the sign convention of object distance, image distance, radius of curvature and focal length. Now the third sign convention is that the height of the object HO are taken positive because it is above the principal axis. The height of the image for the concave mirror taken negative because inverted image is formed. When image is formed below the principal axis, the sign convention is minus sign. So we will put height of the object positive because it is above the principal axis, and we will take height of the image negative when inverted image is formed below the principal axis. If the image is formed above the principal axis, in the case of convex mirror, we will write HI positive, and HO is positive for convex mirror because the object is always kept above the principal axis. Now according to sign convention 1, the direction of ray of light is coming from in front of the mirror. So the direction is the direction of incident light, all distances are taken positive. So when all rays of light are bouncing back in front of the mirror, the object distance is taken negative. For any kind of spherical mirror, if object is placed in front of the mirror, we will put the sign minus because ray of light is going toward the mirror and object is seen from the pole against the direction of light. So this is the reason why we keep the minus sign for object distance. Image distance for concave mirror is taken negative in the same region because object is formed against the direction of light. Focal length is also taken minus sign for concave mirror because the distance of the focus is against the direction of light. So it should be clear here, all the distances against the direction of light are taken negative. Radius of curvature is also taken negative for concave mirror because it is also in the direction of against the direction of light. But in the case of convex mirror, the sign convention number 1, all the distances in the direction of light are positive. We get the image in the direction of light, we will put plus V for object distance. We will put plus R due to the region the distance is in the direction of light and behind the mirror. We will put plus focus because focal length is also in the direction of light. But we will put minus sign for object distance because it is against the direction of incident light. So this is the sign convention. We will make use later on.